Welcome back, boys and girls. It's Thursday. It's the last day of our school week today. Yesterday, we did a little bit of coordinate plane review. And today, we're going to dive a little bit deeper into that coordinate plane review. We're going to find the distance between points on that graph, on that coordinate plane, okay? So, what I've got is this IXL open here. It's 8th grade. Find the distance between 2 points. And you guys might remember we found the distance between 2 points a couple different ways this year. We used the distance formula, and we drew slope triangles and use the Pythagorean theorem, okay? And it says hint, use the Pythagorean theorem, and that's kind of because it's probably the easier way to do this, okay? And we remember that the Pythagorean theorem, I'm going to write it out here. The Pythagorean theorem tells us that a squared plus b squared equals c squared when we're talking about right triangles with right triangles. Okay, right triangles have 90-degree angles. Okay, so that would be a triangle, something like this. It's got a right angle right here. Okay, the two legs, A and B, are the short sides. They're adjacent to the 90-degree angle, and then the side opposite the 90-degree angle, you might remember that's C. That's called the hypotenuse. And if we have two of the three side lengths, we can find the third side length. So what we're going to do is we're going to apply the Pythagorean theorem to find the distance between these 2 points. So I'm going to draw a slope triangle. I'm going to blow this graph up a little bit here. I'm going to draw a right triangle. I'm going to come all the way down here, and then I'm going to come across. Okay, how many units down and how many units across? So I went from positive 10 to negative 6. So this is change in y equals negative 16. Okay, so that side length is 16 units long. And this other side, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That side is 12 units long. Okay, and we can call this one A, and we can forget the change in y. Let's just call this side B. And then we're going to connect those dots, right? I'm going to take this ruler. I'm going to draw a line that connects those dots, and we're trying to find the length of this side right here. Okay, and again, that's called C, or the hypotenuse. Okay, and we know that a squared plus b squared equals c squared. And we said if we have two of the values, we can find the third. So we'll put 12 in place of a, and we'll put 16 in place of b. Okay, we'll grab a calculator. You should always have a calculator when you're doing math. 12 squared, that's 144, plus 16 squared, that equals 400. And if 400 is equal to c squared, we can take the square root of both sides to find the value of c, and that's going to equal 20. So the hypotenuse is going to be 20, which is the distance between this point up top right here and this point down bottom over here. Okay, so it's 20 units in between them. All right, so we're gonna try another one here. It says find the distance between the 2 points. Now I'm going to remind you guys that there is another way to find the distance between 2 points. Okay, we can take our points and label them x1 and y1. Remember, x is first, y is second, and then this one's x2 and y2. And then to find the distance between 2 points, we find the square root of y sub 2 minus y sub 1 squared plus x sub 2, oh, not x squared, x sub 2 minus x sub 1 squared. That will also help us find the distance. So then d equals the square root of, let's see, y sub 2 is 9 minus 1 squared plus x sub 2 is negative 4 minus negative 10 squared. So that's 8 squared plus, let's see, negative 4 and positive 10 is 6 squared. That's equal to the distance. And then one more, we're going to do d equals the square root of 64 plus 36. And d equals the square root of 100. And 100 is a perfect square. We know that 10 times 10 equals 100. Right? So this should be 10 units. We can also, I'm going to do this other thing. I'm going to draw this triangle. And you're going to see 1, 2, 3, 4, 5, 6, 7, 8. Okay, and that's equal to A. And 1, 2, 3, 4, 5, 6 is equal to B. And again, the Pythagorean theorem. I'm going to go ahead down here with the Pythagorean theorem, and a squared plus b squared equals c squared. Again, boys and girls, remember you're pausing the video. You're working on your own on paper with your calculator. And these look very familiar at this point. We're seeing a lot of similar numbers. 100 equals c squared. It's just a different way to get to the same solution. If I take the square root of both sides, then I find that 10 is equal to c. Okay, so the hypotenuse, the distance between these 2 points, c, is equal to 10. Okay, so we're going to put that in. We're going to say 10 units. And we're going to move on. And that's all you're doing, finding the distance between points. Now, this particular one, don't overthink it. It's not tricky. Those things have the same x value. So it didn't move left or right. So all you have to do is go right there and count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 units between those 2 points. And you could use the distance formula if you really wanted to, but there is no point. Don't overthink it. Don't overwork it. Get the answer and move on. This one's the same. You count the distance between the 2 points. Okay? And it's this one on the left is at negative 8x. The one on the right is at positive 1. The absolute value, the distance between those, is 9 units. Okay? And again, you're just counting the number of units in between those. That's 5 units in between. The difference between negative 3 and negative 8 is 5 units. Okay, now we need to draw a slope triangle or use the distance formula, one way or the other. And it's still telling us, hint, use the Pythagorean theorem. I like the slope triangle. I think it's a quicker, easier way to do this. I'm going to draw a straight line. Come on. I'm going to draw a straight line right here, down to there. And then we're going to draw a straight line. Let's see here. straight line right there. And then what we're trying to find is the distance between these 2 points right here. And again, we can use the Pythagorean theorem to find the distance between those points, right? Because this side is called C, and these sides are called A and B. And we just find 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 is equal to B, and A is equal to 1, 2, 3, 4, 5, 6. A is 6 units, okay? So A squared plus B squared equals C squared. Again, is the Pythagorean theorem. 6 squared plus 13 squared equals C squared. And we're looking at 36 plus 169 equals C squared. I think, anyway. Let's do 6 squared plus 13 squared equals 205. And then let's find the square root, second root. 14.317 to the nearest tenth is 14.3. 14.3. And that's it. I'm going to skip and see if we get anything different or more challenging. Find the distance between the points. So now we have to use the distance formula, this one. If we don't have a piece of graph paper and we don't graph these, then we kind of have to use the distance formula. We have to find how far it is between x1, between this point right here, and x2 and y2. And the distance formula equals the square root of y2 minus y1 squared plus x2 minus x1 squared. And y2 is 7 and y1 is 2 and x2 is 10 and x1 is 5. Just finding the difference between those two values. And so now the distance equals the square root of 5 squared plus 5 squared. So distance is equal to the square root of 25 plus 25, which is 50. And it says round the decimal to the nearest tenth. So let's find 50 square root is 7.07. D is approximately 7.07, and it says round to the nearest tenth. So I have to look at the hundredths place right here, and I do D equals 7.1. So that line segment is 7.1 units long. And this is the same thing again. Okay, same thing again. Finding the distance between 2 points. Finding the distance between 2 points. You label your points and you plug values into the formulas that you know, that you've written down. We'll do one more together and then you're on your own. If you would like help, I'll be in a Zoom meeting at 2:30 for you. Okay, find the distance between this point, x1, y1, and this point, x2, y2. These are just 2 points on a coordinate plane. Distance equals the square root of y sub 2 minus y sub 1, the difference between those values, plus the difference between the x values squared. And y2 is negative 18, and y1 is 10. And x2 is 6, and x1 is 16. And we need to find the square root of that whole thing. We're just copying this one step at a time. So distance equals the square root of negative 28 squared plus negative 10 squared. And a negative times a negative is always a positive. So these are going to be positives. And let's see, 28 squared plus 10 squared equals, and then let's take the square root of 884. So D equals 29.73 approximately. To the nearest tenth. So we look at this value right here, and that 3 tells us to stay at 7. 29.7. Let's put that in. And that's it. That's all I'm going to do. And now you boys and girls are on your own unless you come find me in a Zoom meeting and ask for some help. I'm here for you. I hope you have a great afternoon and enjoy. Adios, my friends.